All right, everyone, we're recording. Welcome to our week 8 live classroom. Pretty crazy, we're up to week 8 already. But just wanted to say nice work to all of you last week. Last week was a fun week with a pretty cool assignment, I thought. And before I start with the week 8 lecture, I wanted to go over a couple of things. So if any of you didn't see my email from yesterday, I sent out an email about extra credit. Go ahead and check that out. It's a unique extra credit opportunity. It's worth just as much as your spiritual discussion boards are worth. But yeah, so make sure you check out that email. Were there any questions about that? Just out of curiosity. All right. The next one, I've heard several people talking about the peer review discussion boards being like the blind leading the blind. So let me make a comment on that. So just so you guys know, and I mentioned this at the beginning of the semester, I don't really participate in the peer review discussion boards. I will look at them occasionally. I don't look at every single thread or every single response to a thread, but I do look at them occasionally, but I don't really participate because it's an opportunity for you guys to learn, not just to learn code, not just to learn how to work with others, but also to learn that some opinions aren't always the ones you should listen to. This holds true both in school and in a professional environment. It's just how it is in life. So with this, if you are getting feedback that you don't really think is sound feedback, what I would do is either, if you wanted to make a comment about it, be like, yeah, I think you're completely wrong and here's why. That's totally fine. That's appropriate. Cite your source. Find hard evidence stating why you think you're right and they're wrong. Or if you don't want to mention anything at all, just be like, you know what, that's fine. I know what I need to do with my code, and I'm just going to leave it like that. I had a lot of questions about the assignment where we calculated the subtotals after there was like a discount, and then we did taxes and stuff like that. And apparently someone or some people had mentioned that we need to calculate the tax before we take the discount off, which is false. The way it needs to be is, you take the discount off and then you calculate the tax. So if you have questions about stuff like that, feel free to reach out to me. For different stuff that's actually like a part of JavaScript or HTML, and you can find a source for something saying, stating how something actually is supposed to be, feel free to include it in the discussion. I feel like that helps discussions. But also don't feel like this discussion board is your only opportunity to learn. Ironically, the people in my live classroom right now frequently send me emails when they have questions. There are many students who do not send me emails when they have questions, and then they end up, having a rough time and not enjoying the class as much because they feel like they're being led by blind people in the discussion boards. So with that said, I always say this, but please feel free to email me if you have questions. And in those discussion boards, if you feel like everyone's just lost, shoot me an email and be like, hey, we're all lost. I have no idea what's going on. So any questions about the discussion boards, the peer review discussion boards? Okay. The next thing I wanted to talk about are our videos. So I had some feedback. Let me pull up our video spreadsheet here. So I got some feedback saying that, the introduction to the assignment videos, so this column right here, are extremely helpful in getting people started on the assignments, but there's not really much to pull them through to the end. Now, I can't really make a video halfway through the week and say, here's everything else that you need to do the assignment, because that kind of defeats the purpose of having assignments. However, I do have this column right here for completed programming exercises that correspond with these chapters for each of these assignments. So I would say, because these, I do the entire exercise all the way through from start to finish in these videos. And so if you're wanting help on your assignment, you saw my introduction, you have a pretty good start on it, it's Thursday night and you're not figuring out how to get finished up, look at these completed programming exercises for that week, and watch me go from start to finish through an entire assignment and see what you might be missing, whether it's an input, an output, some type of calculation. But again, these exercises are from the same chapter. And so if it's a chapter on logic, there will be logic in both your assignment and logic in the programming exercise that I'm doing. So that's why I did these videos here. Any questions about that? All right, well then, without any further ado, let's dive into chapter 8. Okay, so repetition. Repetition's a big deal. Nobody likes to write a lot of code when they don't have to, okay? So let's say I was writing Netflix, okay? I have the Netflix website, I'm going to write it from scratch, and I have approximately 1 million movies that I'm going to put onto this website. It would be very tedious to write out 1 million times a piece of code saying, all right, for this div, I'm going to have an image, and for that image, I'm going to have it 300 pixels by 200 pixels, and when they click on it, it'll go to this link, and here's the URL for that link. That would get extremely tedious. Okay, a much more efficient way to do it would be to have some type of a loop or repetition to say, okay, every time I have this thing, I'm going to make a div that looks like this. I'm going to have an image, and when I click on it, it'll go to a link, and it'll be this size, and it'll look like this, and when I hover over it, it'll expand, you know, and I can do that with repetition. And then instead of having to code it 1 million times or however many millions of movies are on Netflix, I can just code it once. All right, so glance at repetition, able to execute the same code multiple times. This always includes a Boolean condition. So similar to our logic chapter, where we're talking about if statements and switch statements, those things always end up computing down to Boolean conditions. And if the Boolean equates to true, then it'll execute that chunk of code. If it's false, it'll skip it and continue. It's the same thing with repetition. So let's say I had 1 million movies on Netflix. I would say, I'm going to execute this code 1 million times. So I might have a counter that says, while x is less than 1 million, execute this code. And every time I go through, I'm going to increment x so that once it hits 1 million, I don't keep on executing the code unneedfully. So in JavaScript, while and for loops are extremely common. These are both generally pre-test loops, which are extremely common, but there are post-test loops, which I mentioned here that aren't as common. I'm not sure if I've ever really seen one in a professional environment, but they do exist. And then there's certain different ways to control loops. The example that I just gave with Netflix, up to 1 million, that's a counting loop where I have a set number of times I'm going to loop through this. All right, so in that example, I would loop through 1 million times, but there's also a sentinel controlled loop as well. And all that means is there's a value that will control whether or not the loop will continue. So let's say I didn't know how many movies I had. I would just say, you know, continue looping until I don't find a movie. Okay, so if I had a massive chunk of data, a massive array of data with a bunch of movies in it, I would just say, you know, until it's done, until I've gone through all of them, then I'll stop looping. Okay, everyone who's joined in the last couple of minutes, welcome. It's good to have you guys. All right, so any questions about this concept of executing code repetitiously or loops? And don't worry, we'll go into examples, but any questions so far? Okay, I'll take silence as a good thing. Okay, so repetition control structures. So there are 4 types of loops in JavaScript. Okay, there's the while loop, there's a for loop, a for each loop, and a do while loop. Okay, this do while is the only post-test loop in JavaScript. There are other languages that have other post-test loops, but it's the same concept. And all this means is, a minute ago when I said that loops, that repetition will always check for a Boolean condition to know whether or not it will repeat. The do while loop has that condition after the chunk of code. So basically that chunk of code that's going to be looped will always get executed at least once, and then it will have that check for the Boolean check to see if it should go back and repeat it or if it should just keep on going. All these other ones, while, for, and for each, they all have a check at the beginning, the pre-test loop. So before any of these execute anything, it will check to see if that Boolean is true. This is very similar to our logic chapter, where we have our if statements. That if chunk of code will never get entered into if the condition for it in the parentheses doesn't equate to true. That is a pre-test for that logic statement. And it's the same thing with these three types of loops. So here's an example of a while loop. Okay, we use while loops for simple counting. And so here's an example of a counting loop. So if I have x equals 0, I could say while x is less than 5, alert x. Okay, and notice right here, I'm going to increment x. This is just our little incrementer that we learned a couple of weeks ago. But every time I execute this chunk of code, these two lines, alert x and x++, will get executed. Okay, so x will start off at 0, and then it'll alert x, and then it'll increment, and x will go up to 1, and then it'll go back to the top of this code. Notice that in here, in these parentheses, this is very similar to what we saw in our logic chapter, or in our selection chapter, sorry, with our if statements. So right here, this could easily be something inside of an if statement. If x is less than 5, do this. And so you could think of this like, while x is less than 5, if this is true, then we're going to execute this code. And we're going to keep on incrementing. And so as soon as x hits 5, it won't execute this block of code again. It'll just continue in the script. Okay, but also we can use a while loop when you can't count and must use a sentinel controlled loop. The sentinel must be checked before executing the statements inside the loop. So here's an example of a sentinel controlled loop. Okay, so x is 0 again, and then we declared sum as 0. Okay, and then right here, we do increment x, but we're not checking for x in this condition in the while loop. Instead, we're checking for sum, and we're saying, while sum is less than 5, execute this chunk of code. So here's a question for you guys. How many times do you think this block of code will get executed? Where sum gets the value of x added to it each time we go through this block of code.
I'll say 5 times.
5 times? Any other guesses?
Infinite.
Okay. All right, so let's think this through. So sum is 0 and x is 0. The first time we run through this, at the end of it, x will be equal to 1. But right here, sum just stayed at 0 because it added 0 to 0. Okay, so now we'll go back through again. And whoever said infinite, you're right in the fact that this will keep on going forever if sum never is equal to 5 or greater than 5. Okay, but the next time we add it, x will be equal to 1, and so we'll add 1 to sum, which was 0, so sum will be 1. Okay, and then we add 1 to x as well down here, and so now x is 2. We'll come back up, x is 2, we add 2 to 1, and now sum is 3. And now x will be 3, and so this next time we loop, sum will be equal to 6, and then x will be equal to 4, but it doesn't matter because we won't come back up here and loop it again because sum is greater than 5. Okay, so this is an example of a sentinel controlled loop. We don't know exactly how many times it will execute it because we're not counting, but we're checking for a specific value to end our loop. Okay, with my second Netflix example, if I didn't know how many movies there were, I'd say, while movies exist or something like that, load the movies or whatever. And that would be an example of a sentinel controlled loop. Do you guys understand the difference between a counting loop and a sentinel controlled loop?
Next time you go out to see the Nielsen's, can you give them this for Maya?
Okay. So here's a for loop. The for loop is a shortened way of writing a counting while loop. You use a for loop when you need a simple counting loop. So I love for loops because they kind of shorten things up a little bit. So right here, a for loop has 3 parameters. Okay, inside of these parentheses, there are 3 parameters. They're each separated by this semicolon. So you have this var I equals 1, and then while I is less than 3, and then I++. So if I go back here, you noticed we declared I before the while loop, and then we declared x before the while loop, and then we said while x is less than 5, and then in the while loop, we incremented x. Okay, in the for loop, we do this all in one line of code. We say var I equals 1, while I is less than 3, increment I. Okay, and the way that this executes is the exact same way. This I++ will get executed after the block of code gets executed. And then, if I is still less than 3, then it'll keep on looping until it's not less than 3. Okay, so here's another example of a for loop. So here we're getting an input from the user, and we're parsing it as a whole number using parse int. And we say, while I is less than or equal to 5, I plus plus. Now notice down here, we don't have anything in the first parameter, okay? But we do have a semicolon there, leaving that space open. This is perfectly legal code, okay? You won't get any errors doing this, even though it looks a little funny, okay? So you can declare I beforehand, or whatever you're going to use to iterate. Usually, or frequently, people use the variable I to iterate just because it's short for iterate. But you can do anything you want. You can name it anything you want. I could have var movies, while movies is less than 1 million movies plus plus. You know, you can do anything you want, but I is very frequent. It's very common to see I in a situation like this. Okay, but it is legal to declare it beforehand, but you still have to leave this parameter open, and then you'll just have however long you want to loop through it, and then however much you want to increment I by. Okay. So any questions about this?
I have a question.
Yeah, go for it.
But it was from the last example you showed us. Would the answer to that be like 4 then, or would it be 5? I didn't get the answer for the last question.
Oh yeah, I guess I didn't. Let's see here. I'm gonna go back to. All right, so let's count through it. So sum is equal to 0. So the first time it gets loops through, sum will still be 0 because x is 0. The next time sum will be 1 because x was 1. The next time sum will be 3 because x was 2, so we added 2 to 1. And the next time sum will be 6 because we added 3 to sum. And then when we go back up to the while condition, is sum less than 5? No, sum is equal to 6, so it will loop through 4 times. And I might actually have, let me see here. So we're in chapter 8. Okay, so I don't have an example of this. But yeah, but we could execute this code and we could just see how many times X would get alerted, and that'd be the same number of times that it'll loop through it. Oh wait, no, sorry, not with this. This one having the alert inside of the while statement, that will alert every time it loops. So if we wanted to check, we could put alert here. But where this X plus plus is being counted, alert X will have the value of the number of times it was looped through. Okay, but it was 4. Does that answer your question, Emily?
Yes, thank you.
Okay, yeah. All right. And then there weren't, excuse me, and there weren't any questions about these examples? Okay, so similar to when we had if statements and the switch statements, how you could do the exact same thing with either one. It's the same thing with the while loop and the for loop. Okay, in these examples, I could do the exact same thing with the while loop or the for loop. It's just a matter of preference. All right, here's a for each loop. A for each loop causes the statement inside of it to be repeated once for each attribute in an object. Use a for each loop when the statements in the loop must be repeated once for each element in an object. Okay, so going back to my Netflix example, if I had 1 million movies in a massive array, I could use a for each loop saying, for each movie in my movie array, do something. Okay, so let's go ahead and play with this a little bit. I don't think I have this written out already. I don't. Hannah, sai daqui, por favor. Vai para mamãe. Vai para mamãe.
Here, I'll just hand my phone.
All right, let me write this out. So I have my template right here. And for this function, I'm going to loop through the object document in JavaScript. So if you think about document, that's where we get our get element by ID function. There's a lot of stuff in document, okay? So I'm just going to write out this exact thing that I have right here. I'll just leave this function the way that it is, the way that it's currently named. I won't have any input, so that doesn't matter. But for my calculation, I will say var text equals just an empty string, and then var or for, and I'll say part in document. Notice how that turned a pretty blue there because it knows that document is a reserved object in JavaScript, and I'll say text plus equals, and I'll say part. And then I'll do some string concatenation here. Plus document part, and then plus, and I'll add a break there, just that it's easier to see what's going on. Okay, and then we'll go ahead and output that. So let me copy this file path and paste it in here, and then run this function. Okay, so I ran this function, and here is everything in document. Okay, there's a lot of stuff, and what I did was I identified the attribute, and then I had a colon, and then the attribute value. Okay, so if right here, if instead of a colon, I put like a bunch of dashes, might be easier to see where that difference is. Okay, so here's the attribute name and the attribute value of everything inside of our document object. Okay, and so notice how I have this object in JavaScript. In this case, I'm using document, but I could use anything like a movie array or something, and I could loop through it. And this part right here, I could name this anything. I could name this item or anything I want to, but it will grab each item in document, and I can isolate the name of that item and then the value by doing this. And let me blow this up a little bit just so you can see it. So right here, I isolated the name of that item in the document, and then when I put it into brackets like this, that's how I isolate the value of that item. Okay, and so if I go in here, let me just open up my developer tools, and we're just going to put a breakpoint in here so it's a little bit easier to see. All right, so I'm going to put a breakpoint right here, right when my loop starts, and I'm going to hit my function button. Okay, so text is nothing. If I look at document, you can see it has all this stuff in here. Okay, and this is the same document we've used this whole time to use get element by ID. Part, you can see it's just a string called dispatch event. All right, and that string will change every time I loop through this. Now it's location, and if I look in document, there is a spot in here called location where it has this location, and then if I F10 again, if I highlight this, I can see what it will get for the location value, and for each time that I'm looping through here. You can see its implementation right here, and what is the value of implementation? It has this, okay? And it will just keep on looping as many times as it has an object or an item inside of the document object, okay? So this is one example of how I might use a for loop, a for each loop, to loop through an unknown number of times through an object. Any questions about this? Okay. Let's move back to here then. All right, the do while loop. Again, this is the only post-test loop in JavaScript, and it's not nearly as common as the other ones. So when to use it? When you can't count and must use a sentinel controlled loop, and the loop statements must be executed before checking the sentinel. So here's why it's probably not very common. Because if we wanted to do a loop with code that had to be executed before checking the sentinel, it'd be easy enough to just put some code up top and then have a loop that would check it, you know. But this is a valid situation where if we wanted to run some code a single time and then check something, you know, we could do that. And here's just an example of a do while loop. So in this example, we declare alias in response. And so this prompt function in JavaScript, if you guys don't remember, it just pops up a little window for you to type in. All it has is just an input and a button to submit that input. So if I hit F12 over here and go into my console and just hit prompt, whoops, you can see it just pops this open and says this page says, and I can type in something and hit OK, and then it comes and it returns the value of whatever the user typed in. So in here, whoops, in here it says alias prompt, what is your name? And then response, I'm taking the variable alias, whatever the user typed in, and said, are you sure blank is your name, whatever they typed in. And then while that response isn't equal to yes, then I'll keep on alerting what is your name until they get the right name. And then we'll alert whatever name they said was correct. Okay, so this is a very simple example of a do while loop where it will do this while this is equal to true. And then it will jump out of it whenever it's false. Any questions about the do while loop? Okay. All right, so different kinds of loops. So each one of these little like columns, I included a while loop and a for loop. In each one of these blocks, the while loop and the for loop do the exact same thing. I included them both just to show you that there's more than one way to write these loops, okay? I could have used a do while loop in here as well, but I just included the while and the for loop. So for the zero-based counting, this is extremely common. Very frequently, we want to count how many things there are. If I wanted to count how many students were in my class, or do something every time something happens, these would all be with zero-based counting loops. So right here, I said var n equals 3 and var I equals 0. While I is less than n, I'll alert leaf. Okay, and then I'll just increment I. So this code right here would get executed 3 times, while I is at 0, 1, and 2. And then I would not be less than 3, and so it wouldn't get executed again. Okay, and this exact same thing could be written in a for loop. We declare n beforehand as 3, var I equals 0, while I is less than n, increment I, and alert leaf. These two pieces of code do the exact same thing. Okay, here's a skipping example. Okay, let's say for whatever reason I wanted to. Here's an example. Let's say I wanted to split our class in half into 2 groups. Okay, and I didn't want, like, you know, alphabetically speaking, let's say I wanted to just alternate who went into different groups. So to do that, you know, I might skip. I'd say, all right, let's say every student had a number from 1 to 30, and I said, all right, every even-numbered student is going to go to this group, and every odd-numbered student will go to this group. Okay, I could do this with a skip counting loop. And all that really means is, instead of incrementing by a single integer, by 1, I would increment by a different value. So in this case, if I wanted to do odds and evens, I could skip by 2, and then instead of just saying I plus plus, I would say I plus equals skip, or in this case, I plus equals 2. Okay, so the way that this would look, I is at 0 currently, and when I add 2 to it, I would then be 2, and then be 4, and then be 6. It would skip values 1, 3, 5, 7. It would skip all of my odd numbered values. In this case, all of my odd numbered students. Okay, and I could write the exact same thing in a for loop. I declare skip beforehand of whatever I want to skip by, and then n declared beforehand as before, and then just I plus equals skip instead of I plus plus. Now, if you're wondering, I don't have to declare skip. If I wanted to just put 2 right here, I plus equals 2, that'd be totally fine as well. It'd be the exact same thing. Okay, so this is an example of how we could use a skipping loop. And then here's an infinite loop. Infinite loops are bad. We never really want to do infinite loops because our computers can do a lot of things, but they can't really handle infinite loops very well. And I'll show you an example here in a sec. So var I equals 0, while I is less than 5, alert hello, and that's it. We never increment I, so I will always be less than 5, and we will alert hello infinity times. Okay, here's the for loop example. If I don't do anything to increment I right here in this third parameter, I will never get incremented. Then there's nothing to stop this loop. Okay. Any questions about these 3 types of loops or any of these examples? Okay. Let's keep going then. So getting out of a loop. So here's a code example that reads 10 or fewer numbers from user and computes and outputs the sum of those numbers. The code stops reading numbers from the user after 10 numbers or after the user enters 0, whichever comes first. Okay, so in this example, we have a prompt for the user to enter a number. So the user will enter a number, we'll parse it right here, and assign that to the variable n. Okay, notice in this for loop, we're saying while I is less than 10, increment I. So at the very most, this loop will run 10 times, from 0 to 9. That's the value of I, while I is at 0 until it's at 9. However, if n is equal to 0, if the user typed in 0 in their prompt, then we will break. And all that means is we're jumping out of the loop. Okay, regardless of how many times we've looped through, we're going to jump out of the loop with this break statement. Okay. All right, so let's look at a couple of examples. And you guys feel free to stop me at any time if you have questions. So here's an example of compound interest. So let's look at our defining table first. So we have our input. We have 3 inputs right here: an amount to invest, or a balance, annual rate of growth, or just the interest rate, and the number of months that we're going to invest. All right, then our processing, we're going to use a loop to compute the balance of an account after a bank has paid interest for however many months. And then the output is the balance after the life of our investment. Okay, so if I look at this here, I have my input, I have our balance, our annual rate, and the number of months. Then we have our monthly rate, which isn't an input. This is part of our calculation here, but this is just annual rate divided by 12. And then right here, I put a comment for each month, compute the interest and add it to the balance. So var month equals 1, while month is less than or equal to number of months, we'll increment month by 1, okay? And then we'll just say interest equals balance times monthly rate. And then we're just going to round this to pennies, which we may or may not want to do. We might want to round it to pennies after our loop. And then we'll add our interest to the balance. And then after this has looped through for however many months the user wanted to, we'll output their total. Okay, so I'm going to copy this file path and paste it in here. Okay, as expected, we have 3 inputs right here. We have our balance. Let's say we're going to invest $1,000 at a 4% rate, and the number of months is 60 for 5 years. Okay, and right here it says your balance after 60 months will be $1,221. That's pretty awesome. Okay, so let's put a breakpoint right here. And if we wanted to, I could put one at the top here, but I know that these are working because we had an output here. So I'm just gonna stick it right here. You can see our monthly rate. We divided 0.04 by 12, and so this is our monthly rate right here, 0.003. Okay. And then right here, month is currently undefined, but we're going to assign the value of 1 to month. And then while month is less than 60, which is what the user typed in, we're going to increment month. Okay, so I'm going to remove this breakpoint and hit F8 to jump to my next breakpoint. All right, var interest is currently undefined, but we have our balance and monthly rate. So our interest right here for this month is 3.3. All right, and then we're going to round that and divide it by 100, and that ends up being 3.33, or $3.33. Okay, and then we'll add that interest to our balance. Okay, now we jump up here again. Our balance now is $1,003.33. We're going to times that by our same monthly rate, add that to our interest and to our balance, and you can see that it'll just keep on going for 60 months, incrementing at a compound interest rate. Okay, any questions about this example? Ana, fecha a porta, por favor. Okay, you guys, I hope that this is making sense. You guys are pretty quiet. I have a couple more examples if you want them. So this one, let's see, determining if a number is prime. So let's look at our slow example first. So right here, I have our factor count equals 0. And to determine if it's prime or not, I'm just going to basically count the number of factors that it can evenly be divided by. All right, and as this increases, I'll just increment this, as well as incrementing the divisor that will control our for loop. And if factor count is equal to 2, then we know that it was only divisible by 1 and the number itself. And so we'd say it's prime. And if it's anything other than 2, then our output would be, then it wouldn't be prime. Okay. So that's an example of how we could see if it's a prime, see if a number that the user typed in is prime or not. A faster example for this, right here, it basically does the exact same thing. I won't go into this too much just because I'm seeing some glazed eyes. But if you want to know about the faster example and why it's faster, just let me know. And then creating repetitive strings or other variables. So this is a very common thing. You notice in my first example that I ran today, when we printed out everything in the object document, I used string concatenation to say, this is the name of the attribute, hyphen, 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 this is the value of the attribute, okay? That was using string concatenation. In this example right here, let's just go ahead and run this. Let me copy this file path. Okay, this program will accept a number from the user and from 0 to that number and save it in a string. Okay, so if I typed in 50, well, let's type in 5 first. Okay, I appended 0 through 5 into a single string and then outputted that string with every number from 0 to 5. So if I look at my code here, I have a repetitive string. I just named it repetitive string. I could name it message or anything else that I wanted to. And I started at 0. And then I said, well, I is less than or equal to user integer, which is what I typed in, which was 5. If I is not equal to 0, because I didn't want 0 to be mentioned twice, then I would add to my variable here. I would add a comma and a space, and then the value of I. And then I would increment I. Okay, so if I typed in 50 over here, as you can expect, it would just go from 0 all the way to 50. Okay, so this is a way that I could use string concatenation and loops to make just a repetitive string to show what all is being computed here. If I wanted, instead of using just a single incrementer, I could say plus equals 2. And this would be like our skipping loop that we did a little bit ago. So if I ran this now, you can see it updated. If I typed in 50 now, you can see I skipped all of my odd numbers, okay? Because I started at 0, and then I added 2 every time. And so I isolated all of my even numbers here. Any questions about this? Okay. All right, let's go back here. All right, so common mistakes. You'll notice some of these are very similar to the if statement chapter, the selection chapter, those common mistakes. One that isn't the same is these infinite loops, okay? If you forget to increment your number or not have a way to end your loop, you'll end up with an infinite loop, okay? Let's go ahead and look at one of those examples. Let me just comment that out. We're not going to increment, and let's see what happens, okay? So I'm going to refresh the page. This is commented out. We're not going to increment. And I'll type in 50 here, and I'll run the function. And see how that button is still pressed, even though I'm like leaving the button, okay? And if I try to, I'm like clicking in this input and it's not doing anything. I can click anywhere I want and it's not doing anything. This is because it's looping over and over and over again. If I stick a breakpoint right here, right now, well, it's frozen. My page isn't letting me do anything, okay? And if I let this run long enough, I'll have a little pop-up from Chrome saying that it like timed out or something. But I basically have to close this. Look, it barely even let me close it. Okay, so that's an example of an infinite loop. It can be kind of hard to detect. If you notice that I didn't have any errors in my console, nothing was red, nothing was like glaring out at me. Stuff just like wasn't working. I could easily be like, man, my computer's tripping. But no, it's because it's doing what I told it to, and I didn't tell it to do good stuff. So that's an example of an infinite loop. Very common error, or a common mistake, I guess I should say. Writing a loop that never repeats. Okay, so this is like the opposite of an infinite loop. An infinite loop executes infinite number of times. A loop that never repeats is one that never gets executed. So right here I say var I equals 0, while I is greater than 3, increment I. I just declared I is 0, so it's not greater than 3. And I increment I, so that's fine, but we'll never execute this chunk of code in this for loop, so I will never increment, and I will never be greater than 3, and the code inside of my for loop will never get executed. Okay, instead I could say var I equals 0, I is less than 3, and then I'll increment I. Okay. Using commas instead of semicolons, this makes sense. Just using like a comma to split up these parameters, but you'll get an error if you try to do that. So let me go back to where I have a for loop. So if I highlight these two semicolons and change them to commas, first off, notice how these colors are different. This one's white and this one's pink. It's never a good sign. Okay, but let's copy this file path and let's see what we get. I'll hit F12. Okay, it looks like I don't have any errors yet. That actually kind of surprises me. I'm just going to type these in, and I got errors now. So if I go to my console, it says unexpected token less than or equal to, future value is not defined. So because it found this error right here, notice it said this was an unexpected token. Because with this comma right here, it wasn't expecting this comparison operator. And then because of this error in this function, it said that future value wasn't even defined. Okay, so yeah, that's a common mistake. If you have your developer tools open, you'll find it quickly because you'll see red errors popping up. All right. Next one, forgetting braces. So notice in this bottom left example, if I don't have my braces there, it won't work the way that I intended to, similar to the previous example. So you always need your curly braces so that the computer knows when to execute your repetitious code. Okay. If you don't have any braces there, there's no way for the code to be like, oh, I'm going to execute this and then stop and then continue the script. No, it'll just continue the script and who knows what it'll do. But these braces are there so that the computer knows exactly what to execute in your loop. Next one, placing semicolons after the parentheses of a loop. So this is one that we talked about with our selection chapter with our if statements. If I put a semicolon right here after our while loop parentheses or after our for loop parentheses, it will end that statement and the loop won't work properly. Okay, so never put semicolons in between your parentheses and your curly braces. Okay. And this isn't a common mistake. I shouldn't have put it here as a common mistake, but this is a piece of advice to use the developer tools, which I can never stress enough. And that's why, you guys saw that example just now where these red errors popped up. It's nice that the red errors pop up instead of me just, clicking over here and having no idea what's going on. Okay. All right. You guys, I just covered a lot. And I know it's a lot. So do you guys have any questions, or are you guys just like, I'm done with this class?
I have a question about the review questions. I was just going over them.
Yeah, go for it, Emily.
There's a couple of questions that ask us to write, like it says, write a while loop to count from 1 to 10 and write a for loop to count from 1 to 10. So does it just want us to put the while and then what's in the parentheses and that's it? Or do we also need to include, what we want to happen?
All right, I'm gonna stop sharing my screen for just 1 second. Let me pull this up. Just don't want to give you the wrong answer. So let me just look at it real quick.
I just did the alert I in the parentheses, so it will show it on the screen, the numbers.
So also include that then in the answer.
Emily, you won't have those questions in the quiz. In the review quiz, those aren't in there at all. So you won't have to worry about, did I actually put the right thing in? So even if you wrote the whole thing for your own purposes, I don't think it will matter because you're not going to be asked that question this week.
Oh, okay. Thanks.
Yeah, so just to second what they just said, it looks like in the actual review questions, it says how many times will the computer display the word flowers, display the word apple, display the word goodbye, things like that, but you don't actually have to write any code for that.
But that's not saying you won't have to do it next week, so.
Yeah, exactly. So when that does come up, just follow the directions. Usually it's pretty straightforward with as far as what you actually have to type out. But if it's not, just shoot me an email.
Thank you.
Yeah. All right, let me share my screen again. Well, any other questions? Garrett, I saw you raise your hand. What do you have, buddy?
Can you go back to, I forget which slide it was, but it was one of your earlier ones. I think it was having to do with a while loop
This one right here?
or do while. Not that one. Try your second or third slide. Oh, wait. Yeah. Okay, that's the one.
The do while?
Yeah. I was just kind of confused. Actually, just straight confused by this
Okay.
program because of the not. If the response is not equal to yes, can you explain? Can you re-explain how this program works?
Yeah. So, you know what? Let's type it out. I feel like this will be easier for me to show you if we just run it. So let me close these. Take my ruined template, which isn't a template anymore. And I'll type this out real quick. So we have our alias response. Minimize our faces. Okay. For our alias and response, just declaring these, not doing anything with them yet. I'm going to delete this for now. And we'll put our nice little do while loop here. So do, and then we'll have while, a condition, and then we'll have alert said hello plus alias. Okay. And then in our do loop, we have alias equals, we have a prompt. And in that prompt, we're telling the user, what is your name? And then after the prompt, we have a response. And in this response, we have another prompt. It says, are you sure? And then I use that variable, that alias is your name. Okay, so let's blow this up a little bit. Here's our code. So if I look at this, if we think about this, every time this program runs, we're gonna have two prompts, two of those little windows popping up, right? First one is, what's your name? And I'll have a little space to type in, and I'll just type in Nathan, okay? And then it'll say, are you sure Nathan is your name? Okay, but it's another prompt. So it's asking me again, if I'm gonna say, is this your name? Yes or no? Okay, if I say yes, then it'll say, hello, Nathan. If I say no or anything else other than yes, it will not go down here. Instead, it will execute this chunk of code again, and it'll say, okay, then what's your name? Are you sure that that's your name? Until I say yes. Okay, so another way of writing this, if we look at this right here, I wrote, while response is not equal to yes. Okay, I could also say while response is equal to no. Okay, and that's the exact same thing, I guess, if there were only two options. So let me copy this file path. And run it. So I guess I'm not doing anything with that. So my name is Nathan. Are you sure your name is Nathan? If I say no, it'll ask me my name again. It ran that first chunk of code again. What's your name? Okay, so now I'm going to type in Jeremy. Are you sure your name's Jeremy? No. Garrett? Yes. And then it says, hello, Garrett. Okay, and so it kept on executing this until this was false. Okay, so the second this equated to false, it jumped out of my loop. Okay, and so in this case, I said, well, response is equal to no, while they say, are you sure your name is whatever? If I say no, it'll keep on looping. Okay, but as soon as I said yes, it jumped out and it said, hello, Garrett, in this example. But that was the exact same thing as if I did yes. Okay, so while the user doesn't say yes, we're just going to loop until they say yes, and then we'll say hello to whatever their name is.
So, so basically, the loop will continue until whatever's in the while parentheses is true.
While
Okay.
it will continue while this is true.
Okay.
As soon as this is false, it jumps out of the loop, and it continues my script.
Okay, that makes
And
sense.
yeah, and it's that same principle. So if I look, let's see, like at these other chunks of code, these loops, all of them will continue while these conditions are true. Inside while parentheses and in this middle condition in the 4 parentheses. Okay, while those are true, it will continue to loop. And it's the same thing with this do while example. While this inside of the while parentheses equates to true, it will do the do while loop. Great question. All right, any other questions?
Brother Birch, I had a question for you.
Yeah, go for it.
And I mean, this sort of, I don't know if you want to go back over this, but when you were going to explain there for a second, those difference between the fast, the prime numbers, the fast way and the slow way. Do you mind explaining those? Because I was looking at those at the review and I was like, I sort of get it, but I don't get it.
Okay, so let's check this out. So this is the prime slow. All right, I have a for loop right here, and while divisor is less than or equal to candidate, we're going to increment divisor. Okay, and then we'll check to see if candidate is divisible by the divisor. Remainder, if remainder is equal to 0, then we'll increase our factor count, and the factor count will increase anytime it was divisible by something. And so if I had 6, it would be divisible by 1, 2, 3, and 6. And so if I had 5, it would just be 1 and 5. Okay, and so then we would know if something was prime or not. Okay, now the same thing with this right here, but here's the difference. So here I have a break. Okay, the only reason why this is the fast one and the other one is the slow one is because of this break. Okay, now we can't really comprehend, you know, in our like heads with our brains, we can't say, oh yeah, this was like 0.5 milliseconds faster than the other one, you know, but because I have this break here, immediately, so right here, I'm checking to see if it's divisible by that divisor. And if remainder is 0, then I just say, okay, prime is equal to false, and then I break. All right. With the other one, I kept on looping over and over and over again, and that wasn't necessarily needful. If I look at this one right here, I check the remainder. Okay, and if remainder is equal to 0, then our factor count equals plus plus. Okay, so let's say I had the number 22. No, that's a bad example. Let's say I had the number 20. Okay, 20 is divisible by 1, 2, 4, 5, 10, and 20. Okay, those are all the factors of 20. So if this prime slow example found that remainder was 0, then it would increase this factor count, and this factor count would go up to 6, and then it would see that, you know, it's not equal to 2. It is indeed, it's not a prime number. Okay, with this other one, as soon as it finds that remainder is 0, then it says prime is false, and then it breaks. Okay, and then it just checks that value down below. Okay, so in that example of 20, I wouldn't have to loop through every time to see, oh yeah, you know, there's 6 factors in 20, you know, but as soon as it finds that there's multiple, it'll just be like, oh, yep, that's not a prime number. Does that make sense?
Yes.
Okay, it'd make a really big difference with numbers like 200 that have like a bunch of factors, you know, because otherwise we'd have to loop through like 200 numbers to check, at least 100 numbers to check to see how many factors there are, you know. But with this fast example, it would just be like, oh, you know, I found multiple matches, you know, it's not a prime number. Okay, great question, Garrett. Or sorry, James, great question. All right, any other questions, you guys?
I have one. I just thought of it. You were talking about the difference. Can you clarify really quick just what the difference between a counting loop and a sentinel loop is?
Yes. So this, let's see here. Let me go back to my example here. A counting loop is anytime you know exactly how many times you want to loop through something. So if I wanted to find all of the prime numbers between 1 and 50, for example, I know that I would loop through 50 times, and in those 50 times, I would just count how many prime numbers there were. Let's say I wanted to do a loop until I had 3 prime numbers. Off the top of my head, I don't know how many prime numbers, I don't know what the third prime number is. you know? So with that example, I would say, okay, I'm just going to loop through until I have 3 prime numbers. So with this piece of code right here, you know, I could make a loop that counts how many prime numbers that I have. And as soon as it finds a prime number, then I would just say, okay, prime plus plus. You know, I found my first prime number. Prime is I now have 1 prime number. And then as soon as I find my second one, I'd say, okay, prime plus plus again. I have 2 prime numbers now. And so I wouldn't know exactly how many times I'm going to loop through to find X prime numbers, or to find whatever the 5th prime number was, or something like that. And so I would use a sentinel controlled loop to say, all right, you know, whenever this number equals 3, whenever I have 3 prime numbers, or whenever some condition is true, I'm going to stop looping. Okay. So anytime I can count, great. I'll want to count. But if I'm going to say, all right, you know, until the user says, yes, this is my name, or until we found our 3rd prime number, or something like that, or until every attribute in the document object was printed on the page. Those are all examples of sentinel where we don't know how many times we're going to loop through. So we can't just say, while I is less than 10, for example. Does that make sense?
Yeah, that makes sense.
Okay, awesome. All right, any other questions? Okay, again, a shout out to, oh, I think I closed it. Oh, no, it's right here. Okay, a shout out to this right here. I do have a full example of 2 exercises in this chapter, exercise 1 and exercise 10, that have to do with repetition. And I have this assignment introduction for assignment 8 that you can also look at. So I would encourage you to look at these exercises and how I did them. If you want to give it a shot, try to do those exercises before looking at the video. But those are there for you guys. So, all right, last call for questions. Okay, well, everyone, it was great to have you in class today, and I will post this as soon as it is available. So, all right.
Thank you.
Hey,
Thank you.
thanks.
You're welcome, you guys. Have a great week.
You too.
All right, bye-bye.